Here we go. Alright, so when we're asked to add them, the first step is still always to simplify. Does anyone, without doing the process, know what square root of 18 would be? So we can't add them first because they aren't like terms. Remember, when we get to adding and subtracting, we can only do like terms. So we can only add them if they have the same square root, the same number in the square root. Yeah, so it's 3 root 2. We know that because it breaks down to 2 and 9, which is 3 and 3. Alright, does anyone know what root 32 breaks down to?
Is it 4 to the square root of 2?
Mm-hmm. So
The double stay outside.
So it would go to 2 and 16, which is 4 and 4. So double stay outside. Alright, anyone know what root 75 goes to? 3 and 25, which is 5 root 3. Alright, you guys, we are doing one talker. I should not hear any side conversations going on. Okay, so now that I've simplified them, do I have any like terms I can add? Which ones? The first two. So like terms mean they have the same square root, and I only add the numbers in front, so that becomes 7 root 2 plus 5 root 3, and that's my answer. Okay, so when we're asked to add radicals, we have to simplify and look for like terms. If there's not a like term, it just stays separate. Alright, how many of you remember dividing radicals at some point in your math career?
Like, remember doing it, or like remember how to do it?
No, remember doing it at some point. Okay, so about half the class has at least remembers doing it. Do any of you remember how to do it? No. Okay, so the rule with dividing radicals is we can't leave radicals in the denominator. I would write that down. So if we have something like this, 5 can't be divided by 3, but what I'm going to do is I'm going to multiply the whole thing by a factor of 1. So I'm going to multiply a whole thing by root 3 over root 3 because I can't leave that square root in the denominator. And so the simplified step, if you can't just actually divide it out, is multiply by whatever's in the denominator. And so what is root 5 times root 3? Root 15. What is root 3 times root 3?
That's 13.
Oh my goodness, that is 13. Thank you.
Root 9.
Yeah, so then that's root 9, which simplifies to just whole number 3, right? Okay, so the 3's still in the denominator, but I can't leave the square root symbol down. I can't leave a square root in the denominator, and so I have to multiply by whatever it takes to make that a whole number. Okay, that's a lot of really confused looks. Would it help if I explain the steps again?
Yes. Very slowly.
Where did this come from? I don't remember doing this.
You don't remember doing this? It's possible you didn't.
No, and where was like leading?
Alright, so if you've never seen this before, just remember the rule is anytime you see the division sign, we're just simplifying to make sure we have no radicals in the denominator. So my steps are, and if this is new to you, maybe write out what the steps are. You multiply by a factor of 1 that's the same as the denominator. And so that gives me, I multiply just the top and bottom by root 3. So 5 times 3 to get root 15, 3 times 3 to get root 9, and root 9 simplifies to 3. Okay, so stick with it if this seems really new to you. This one, first I'm going to see, is there something I can divide first?
No.
Yeah, 4 and 2 still divide. So if there's something you can divide, you divide first. So first step is I go ahead and divide that out to get 2 root 3 over root 2. What am I going to multiply it by?
2.
By root 2. And so when I'm multiplying, I just multiply square roots. You don't multiply the whole number unless there's another whole number there. So that gives me 2 root 6 over root 4, which simplifies to 2 root 6 over 2. And is there one more thing I can do?
Divide out.
Yeah, those cancel out, so my final answer is just root 6. Isn't that awesome? When I can take that and simplify it to root 6. You know you love it, right?
No.
My whole class. Don't you love taking that and putting it to this?
No!
It's so nice and neat.
Remember when am I ever going to use this in real life?
Yeah,
Never.
You're going to use those thinking skills in real life.
I think we're going to have calculators.
I think off my feet.
We're gonna have robots doing it for us by the time we graduate college.
All right. So, what do we have? Who remembers factoring?
Yeah.
At least half my class, right?
I know what it is.
Okay. What's my first step?
Is that where like you have to get that number has to add up to that number, but multiply whatever?
Yeah. And so, first step, we put everything on one side, so we want it to equal 0. So this gives me x squared minus 16 equals 0. Okay? So this one's a little different. Normally we say, okay, what multiplies to the last term adds to the middle term. Did I do something wrong? So what is is there a middle term here? So technically that middle term would be 0. How do I multiply to negative 16 and add up to 0?
Plus 16.
You have to multiply.
Okay, so what are the ways I get to negative 16? Yeah, so 1, 16, 2, and 8, 4, and 4, right? And for it to be negative, one of them has to be negative. Which of those would cancel out to 0 in the middle?
4.
4 and 4. So that just gives me x minus 4, x plus 4 equals 0. And so then my answer is just the opposite of those numbers that would make them equal to 0. So x equals either positive 4 or negative 4.
Just start repeating right after that, like that.
Yeah, so when you have factoring, you always have two answers. You learned how to like look up the factors in the calculator, right?
How do you do this?
So you go to graph.
It's the same. The calculator does, it gives you this list. So if you don't know your factors well and you want to type it into the calculator and get the chart, but it takes more time unless you just really don't know your factors. All right. Number 6. What do you think the first step would be? Yeah. So when we're gonna do exponents first, and so we're going to actually it is kind of distribute. When you do exponents, when the exponent applies to both terms inside that parentheses. So we do 3 squared, root 5 squared.
So it would be 8.
No.
14.
So 3 squared is 9. What's square root of 5 squared?
25. Oh, no,
It's just 5.
Yeah. So it becomes root 25, which is just 5. Okay, when you square root, it becomes a whole number. And then these are still multiplied. So multiplied, so it becomes 45. All right, and then here, so that's our first parentheses. This becomes 3 squared and root 2 squared. All right, what did I do wrong?
I can just do this.
Because that's algebra 1. We're in geometry now, so you have to take it farther. Okay, so what am I going to do next?
You gotta add them together.
Add them together. What's that become?
Oh, God.
63.
62. No, 63.
63. So 63 equals x squared. What would I do next?
Add a 0.
Do 2 squares.
No, when you square root the x to cancel out the...
Yeah.
Is this going to be like a homework?
Yeah.
Oh, big idea.
Today's homework's on paper. Okay. So here I just. Okay. So it does become. It becomes square root of 4, which is 2.
Yeah, I want it. Totally.
What?
She didn't care about anybody that time.
Okay, you guys, how do we feel about this? Thumbs up, medium, down?
Wait, what?
How do we feel about these steps so far? Because I'm getting some questions. Okay, so stay with me. Show me how you felt about this step where I just distribute the exponent.
That's easy.
Okay, you guys are with me in that step. Do you understand how that actually multiplied out to 9 times 5 and 9 times 2?
No, it's 3 squared. 3 times 3.
Okay, so y'all are with me in that step.
25. Yeah.
Do you, and so you understand how that's now 45 and 18?
Yes, because you add.
And so then is it this step that's confusing?
Yes.
Okay, so here what we do, and we could have solved this one this way too, if just doing x squared equals 16, and then you take the square root of both sides. If you only have 2 terms, that's another way you can do it. So if we have just x squared equals something, the easiest thing to do then is take the square root of it. We just have to remember that we have a positive and negative answer. And so my answer would be just written like this, so plus or minus, so plus positive negative sign. And we just have to simplify out root 63. So what does 63 multiply? Simplify 2. 9 and 7, and 9's that simple square of 3, perfect square of 3 and 3. So it becomes 3 root 7.
What? I wasn't listening.
So I took the square root, and then when we simplified it. So 9 and 3, square root of 9,
So you just
9
take
and
the
7.
smallest one here, go from the top to the bottom. Because there's like 163, 321.
You're looking for the one that's perfect square, so 9's the
39.
yeah, 9's the perfect square.
Oh, how do you simplify that?
Mm-hmm.
You get it. Okay, I get it now.
So then
All right. Do you guys want to do the next one in your groups or do it together? Groups? Okay. Do the next one. See if you can do it in your groups.
Oh, okay.
All right. Do I have a volunteer here? Those of you who got it, what did you say your answer was?
We got x minus 8.
Okay, well, wait. I called on Kayla.
Oh,
So 2 or 8 was what Kayla got. Who agrees?
wait. You gotta go through the
Wait,
process
isn't it negative
first.
2? Shouldn't it be negative 3?
Okay. So let's go through the process and see. So what is our first step? Yeah, so first step, we add 16. So we have x squared minus 10x plus 16 equals 0. Okay, so remember you have to get everything on the same side of the equation before you factor it out. All right, next step, you can draw the box if that's the way you learned it. You can just figure out what multiplies to 16 and adds up to 10. And so, you guys want me to show you the square?
No.
Wait, squares. No, that's gonna make stuff complicated.
No.
Okay.
Wait. Wait, you can actually use Punnett squares?
Yes.
I was just kidding. Like, I didn't even know.
Okay, so when you do the square, we figure out this. You still have to pick your factors though, right?
Yeah.
So we find out, okay, 2 and 8 is what adds up. I know it's a positive 16, so I know they're going to add. They're going to add up to the negative 10.
we did,
Yeah.
And so then that becomes negative 2x, negative 8x. And then my actual factors are
So
x's in both of these.
X minus 8 minus
No, that'd be
Okay. Some people find that a lot easier visually.
No, I like it.
I don't find it easier. I find it more work. And except when we get to these, it can be a bit easier. Okay, so then those are my things that equal 0. And then I have to take the opposite of them. So x minus, if I cross off this, so x minus 2 equals 0, I need it to be positive 2. Or if x minus 8 equals 0, I need it to be positive 8.
What?
Okay.
I like the other way better.
So stop and think. I heard lots of questions there. What? This is the only way. I mean, you either do it this way or you just come straight to this step. Okay, so those of you who are saying what, can you stop and think? Let me know which step didn't make sense.
No, I get it.
We just need a minute process time. All right, number 8 is even easier, okay? So, all right, y'all with me still?
No.
Yes.
Okay, if you said no, can you tell me what part you're not with me on? Or do you just need a little process time? Okay, so we're going to do these last 3 examples. And if it's not making sense, as we get to the practice time, individual practice, that's the time to make sure you get your questions answered. Because I wrote you plus pass and you didn't come in. So I need to talk to you about what happened.
Is mine up there?
Add a 0. And a 0.
Oh, I have to do my test.
Alright, so let's go back to our one talker and look at example 8. It's just a little different. What's different about it?
It's already 0.
Yeah, it's already equal 0 and there's no there's no third term. Yeah, there's no C. And so what we do here is we look for, is there a greatest common factor? Is there something that's in this and this that I can just factor out? Yeah, 1x, right? And so the way you factor these, you just take x out of each, so I'm left with 1x here plus 5 equals 0. See how easy that is? We just take the x out of each. That's called factoring, greatest common factor. And so now, no, I'm factoring. I'm going opposite. So that was the opposite of distribute. So now again, if x times x plus 5 equals 0, either side has to equal 0. So either this x equals 0. Okay, so x could just equal 0, and this would be a true equation, right? Yeah. Okay, because then it'd be 0 times 5 equals 0. What else could x equal? Well, negative 5, yeah. And so again, I just split it up into 2. So I'm like either x equals 0 or x plus 5 equals 0, which means I do minus 5. So if you factor out an x, 0 is one of your possible answers. Okay, you ready for the big ones?
No. Stop.
Okay, we got to do the examples. You need a minute to do this?
Alright, let's see if I can do this by myself.
Alright. Let's do the next one together, and then you guys can do the last one by yourself or with the group. So, what's the first step, everyone?
It's 12.
Yeah, so now I have 2x squared minus 5x minus 12. Does anyone remember what we do when we're factoring when a is greater than 1? When we have 2x squared? What's the first step?
Oh.
We have coefficients in this one. Oops, sorry, say that again.
I don't know how to explain it, but I know when you're factoring, you've done it 2x.
Yeah. So there's 2 ways to do this. You can kind of do like trial and error and say, okay, what's going to multiply? Because I'm going to have a 2x in there, still multiply to get 12 and get a 5 in the middle. The way we usually teach it is you do this in-between step of multiplying 2 by 12. And so I have an in-between equation to factor that gives me x squared minus 5x minus 24. Okay, equals 0. And this is one I do use the box for. It seems to work the best. And so I still know my original equation is going to be, I'm going to have the 2x squared and the negative 12 here. this in between one where I multiplied helps me figure out which two numbers go there.
I get the.
And so I take my negative 24, and because it's negative, I'm going to see what multiplies to 24 subtracts to 5. And so 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so 3 and 8, those are the ones that are going to subtract to 5. Which one has to be negative? Negative 8. Okay, so those go in here. So negative 8x and negative 5x will be those, sorry, negative 3x.
This makes sense. No, it's
Sorry, positive 3x, thank you. Okay, so I multiply first and last terms to figure out what goes in these boxes. And now I go ahead and see, so 2x squared and 3x, what's our like term there? Just x, right? Negative 8x and negative 12, what's there? 4 and positive or negative? Negative, right? So when I do columns here, I'm saying just what's my greatest common factor of these two terms. So here these both have an x in them. Here they both have negative 4 in them. Going sideways, what do these both have in them? 2x. Going sideways, what do these both have in them? 3 and positive 3, right? And then, so that's my answer. So 2x plus 3 and x minus 4 equals 0. So I still need them to equal 0. So what do I do? This one's easy, right? So x could just be, x can equal positive 4. What do I do when there's two terms, like when there's 2x? So I have 2x plus 3 equals 0, and then I solve. What's the first step to solve? And so then 2x equals negative 3. I ran out of space on my paper. And then I divide by 2, right? So, so it becomes negative 3 over 2 or negative 1.5. So if you like memorizing patterns, the pattern's always just going to be negative that number divided by your coefficient. So negative 3 over 2 or 1.5. Okay, we're going to take like the next 2 minutes, see if you can do the last problem on this page with your brain. Is fried. I know. These ones tend to fry brains. All right, see if you can do it.
This is stressful.